In the same way that we can use those operations on numbers, we can also use them to combine entire functions. So the way this looks is, if we have two different functions, f of x and g of x, we can do operations with them and combine them. So you can have the sum of functions, and these can be written two ways. We can have the actual f of x, and it'll say f of x plus g of x. Or you may see it written like this, f plus g of x. Those mean the same thing. We're going to combine them by adding. It's just different notation of how it's setting up the problem. Okay, so then difference means subtraction. So we could have f of x minus g of x. You'll have to be careful with subtraction because you'll have some distribution to do when you get to that step. Or you could see it written like this, f minus g of x. Product means multiplication, f of x times g of x. Or f times g of x. And finally, quotient would be division, f of x divided by g of x. Or in most common, you're going to see it written like this, f over g of x. Functions given. So they tell us that f of x is 5x minus 8, and g of x is 7 minus 2x squared. And they say find f plus g of x. We're going to take f of x, which is 5x minus 8, and then add g of x, which is 7 minus 2x squared. And then we just combine like terms. The only like terms we have are the constants in here. And then put it into standard form for your final answer. So largest exponential term comes first, 2x squared plus 5x minus 1. And that is f of g of x when we add them, or not f plus g of x. Number 2, it says to find f minus g of 4. So first we have to find f minus g, and then we will plug in 4 to find the value of that at 4. So if we do f minus g first, f of x is 5x minus 8, and then we are going to subtract g. So put it in parentheses, because we're going to subtract the entire function, and then distribute that negative sign to both, because you have to subtract the whole thing, so subtract both terms. 5x minus 8 minus 7 plus 2x squared. So then fully simplified, 2x squared plus 5x minus 15. Then our last step, because it asked us for f minus g of 4, is we are going to plug in 4 for every x that we see to get the value of that function at 4. So 2 times 4 squared plus 5 times 4 minus 15. Remember, order of operations, we have to do the exponent first. 4 squared is 16, so we get 32 plus 20 minus 15. And then when we just do our math across, this ends up being 37. As always, you need to watch for domain issues. So we're always watching for domain issues when you combine function, especially when, which operation do you think is going to present us with domain? What? Yes, but like what, addition, subtraction, multiplication, or division? Division. Okay, so especially when dividing, because you're going to end up often with an x in the denominator, and we know that that is a problem. So we watch for those domain issues. We are going to pay attention to denominators, which present domain issues, and square roots, which restrict our domain as well. So those are sort of things we're looking for as we combine functions. Okay, the domain of the new function, when we combine two functions by adding, subtracting, multiplying, or dividing, the domain of the new function will be wherever the two original domains overlapped, which is called an intersection. That's like the math term, but it's basically where they both have values. So it's where they overlap. Then the domain of the new one will be wherever they overlapped to start. Or where they have discontinuities if we find domain issues. Those, we have to restrict those. So for example, if we have f of x equals x to the third, before we do all of our combinations, let's identify the domain and where the domains overlap. What's the domain of x to the third? What's the domain of just a cubic function? Close. All real numbers. A cubic just goes like this, right?
Oh, that's right.
So it's just negative infinity to positive infinity, everything. There's no domain restriction. Are we going to have a domain restriction here?
Yeah.
Square roots, that's something we're looking for. Remember, in a square root, we have to have the radicand, the value underneath the radical has to be greater than or equal to 0. We can't get a negative radicand. So remember, for square roots, we take that radicand and say, tell us when this radicand will be greater than or equal to 0, because that's my domain. So in this case, if we solve for x, x must be greater than or equal to -1. So then to write that in interval notation, the domain of g of x is from -1. We include it because it can equal -1, and anything bigger than -1, so to infinity. So what is the domain of these two functions? Where do they overlap? Which one is part of the other one?
Infinity.
This one.
-1.
Yeah. This one fits into the other one. Do you see that? So like this is the more restrictive domain. That's going to be the domain of our new function when we add, subtract, multiply, and maybe divide. We'll check more closely with division. So let's start with addition. If we add our functions, we do x to the third plus g of x, which is square root of x plus 1. Now the domain we said will be where the original two overlapped, and the place they overlap is the more restricted domain, so the one that has more limitations to it. If I from -1 to infinity, again, because it's where they overlap. And if we check it on a graph, we'll see that. So we'll take f of x divided by g of x. Now what do we know? What's going to be a problem? The denominator, we have a domain issue because of the square root and because of a 0 potential. So in our everything so far domain, we included -1. Can we include -1 now? Why? Because we'll get a 0 denominator. It was fine to get a 0 square root on the top, but it's not fine to get a 0 square root in the denominator. So we have to change our domain to not include -1, because that'll give us a problem. We just plug in the given x value and find the y value. So if we were going to do f of 4, we would plug 4 in to our original function. Right? So we'd plug in 4 for x, we get 16 minus 8 plus 7, 15. F of 0, we'd plug in 0. 0 squared minus 0 plus 7, which is 7. Be super careful with your negatives always. -1 squared minus 2 times -1 plus 7. So we get 1 plus 2 plus 7, which is 10. Okay, so we're pretty good at that, plugging in just a point to get an output. So putting an input, getting an output. But here's what we're going to do now. We can also plug entire functions into other functions. So rather than just plugging in a number, like 3, you're going to plug in a whole function into another function. So you might be given like x squared plus 2x plus 1, and you have to plug it into another function wherever you see an x. We call this composition. So combination is where we're adding, subtracting, multiplying, or dividing. Composition is where we are putting one function inside of another. The way that you will see composition written is one of two ways. So you need to know this. I will not answer this on a test. Someone will ask. Okay. It's a little dot. It's not an O. It's like a dot. The other way you might see it written is like this. F of G of X. Okay? Either of these, both of these mean the same thing. And the way that we say it is F of G of X. Okay? So we're constantly thinking about domain. I know I am. I'm sure you are. We're always thinking about the domain. The domain of the composed function, so when we put one function inside the other, it will be determined by where the innermost function exists. Okay? So the one that's being put inside of the other. So let's talk about it. Okay. Here we go. Okay, first it says find f of g of x. So we are going to start with our f of x, which is x squared plus 2x minus 1. And everywhere we see an x, we are going to plug in g of x. Okay?
What?
So, 1 over x minus 2 squared plus 2 times 1 over x minus 2 minus 1. I'm not going to do a ton of simplification here. We're going to get it mostly simplified. The only thing you really need to do to simplify is just multiply in this 2. So I'd accept your answer like this. 1 over x minus 2, that quantity squared, plus 2 over x minus 2 minus 1. Okay, and you can leave it like that. The domain of our function, now that we have composed it, what did we say? It was going to be the domain of the innermost function. So our innermost function is the one that we plugged in, which is this. Right? That was our innermost. That's the one we plugged into the other one. What is the domain of this function? I'm so glad you volunteered. I bet you were. No. Where do we have an issue in this function?
-2 or 2. 2 equals 2.
X cannot equal 2. What kind of a discontinuity is it? Infinite. We're going to write it in interval notation. So where does it exist? From negative infinity to 2, but not at 2. U to infinity. That means everywhere but 2. G of f of x. So we're going to start with our g of x, which is 1 over x minus 2. And we are going to plug in f of x wherever we see an x in our g. So we'll say 1 over, then plug in x squared plus 2x minus 1 minus 2. So do you see how we plugged in our other function for x?
Yes.
Then our last step is like, essentially we can take out these parentheses and combine the like terms. So our answer is 1 over x squared plus 2x minus 3. Okay, are we going to have domain issues? Yes, because we have x's in the denominator. How do we figure out what they are? Factor. -3, +2, 3, -1. Right? 3, -1.
So it can't be -3 or 1?
Good. X plus 3, x minus 1. If we set each of these equal to 0, we're going to have an issue when x equals 3 and when x equals 1. So what did we... We said the domain issues are going to happen when x is -3 and when x is 1. Write this in interval notation. Yep.
Infinity, -3.
Yep.
U, -3, -1. U, -1.
Yeah, positive 1.
Is it positive 1?
It is. 1 to infinity.
Okay.
That is a weird infinity. Okay, so then a couple more just little compositions. So if f of x is 4x squared and g of x is, we're going to change this. I'm going to do these as parentheses, not as absolute value. G of x, so make sure you change that in your notes, is 3 minus x. First it says find f of g of x, and we're going to do f of x, so we're going to start with 4x squared, and there we are going to plug in g of x where we see the x. So we're going to get this 4 times 3 minus x squared. And then we need to keep going. Order of operations says I have to square this binomial first. So I'm going to just FOIL that out, which gives me 9 minus 6x plus x squared. So now I'm here, 4 times 9 minus 6x plus x squared, and then I will distribute in the 4, and I'm going to put it into standard form. So my final answer is 4x squared minus 24x, 9 times 4 plus 36. So that is f of g of x. And then any domain issues on this, there are none. It's just going to be a quadratic. So the domain is going to be from negative infinity to positive infinity. If we go the other way, g of f of x, we're going to take our g of x, which is 3 minus x, and we are going to plug in f of x where we see x. So we'll say 3 minus, make sure you put it in parentheses because that negative sign is going to have to distribute. 4x squared, which simplifies to 3 minus 4x squared. In standard form, we'd say negative 4x squared plus 3. And then if we look for any domain issues, again, this is just a quadratic, so there's nothing jumping out at us like a root or a denominator, so our domain is just going to be from negative infinity to positive infinity. Then it asks us to find g of 4. So, sorry, f of g of 4. So we are going to work from the inside out. First, we're going to find g of 4. So we go back to our original g of x, which is 3 minus x, and we plug in a 4. So 3 minus 4 equals negative 1. Then we're going to find, because now we've turned this into 1, so now we're going to find, or negative 1, f of negative 1, which means into our f of x, we're going to plug in negative 1 wherever we see an x. So negative 1 squared is 1, 4 times 1 is 4. So work from the inside out, find g of 4. When you get that number, you find f of that number using your original functions. Okay, the last one is just a word problem, doing a little bit of application of this. So it says the number of bacteria in a container of leftover food in the fridge can be modeled by n of capital T equals 60t squared minus 140t plus 76, where T is degrees Celsius. When the container is removed from the fridge, the temperature is T of little t, where little t equals time in hours, right? A function that models the number of bacteria present after T hours unrefrigerated. How many bacteria will there be if the food is left out for 2 hours? So we have two parts here. First, we know that N is the number of bacteria. Big T is the temperature, and little t is time. And they're asking us to relate the number of bacteria to the number of hours. So we have to basically go from here to here. So in order to do that, we have to compose the function. We have to take n of t of little t. So we're going to start with our n of t, which is this. 60 big T squared minus 140t plus 76. And wherever we see a t, we are going to plug in t of t. So we're going to compose this function. So we're going to do n of t of t. So 60 times 5t plus 3 squared minus 140 times 5t plus 3 plus 76. And then from here, so this is my composed function. That is relating the number of bacteria to time by putting those together. Then it asks us how much bacteria will there be if the food is left out for 2 hours. Now we're going to find when t, time, is 2. So we plug in 2 for t. Oops, 5 times 2 plus 3 squared minus 140 times 5 times 2 plus 3 plus 76. So order of operations, start inside our parentheses, 60. 10 plus 3 is 13 squared minus 140 times 5 plus 2 is 10 plus 13 plus 3 is 13 plus 76. Then we square 13, whoops, which is 169 minus 40 times 13, 1820 plus 76, and then 60 times 169. It's 10,140 minus 1820 plus 76, which tells us that after 2 hours, there were 8,396 bacteria. So always label your word problems.